So we're here at the example table, and in this video we're going to find the difference quotient of the function x minus 1 quantity squared. So let's just take a moment to remember what's going on with the difference quotient. If we have a little function here, let's call it f. It's not the same f. Difference quotient is the slope of a line like this. So let's say that we have the point x here and the point x plus h over here. That means in particular that the distance between these two things is h. So now if we trace each of these points over to the y-axis, this is f of x. And if we trace this one over, it becomes f of x plus h. So the difference quotient is the slope of this line. Slope is rise over run. This is change in y over change in x. And in this case, change in y, it's the difference here, so we get f of x plus h minus f of x, that's the change in y, all over the change in x, which is h. So this is the formula for the difference quotient. It's a formula you should know, but knowing where it comes from will help you remember it. So know where it comes from. It's just the slope of a line. So let's look at our particular example on a clean sheet of paper. So the difference quotient for us, well, it's f of x plus h, let's write down the formula, minus f of x all over h. So wherever we, for this f of x plus h, wherever we see an x in the formula, we substitute x plus h. So we get x plus h minus 1 squared for that first part, minus x minus 1 squared all over h. So what happens when we expand the top? So let's pause for a moment. We were asked to find the difference quotient for the given function. We just found it. So why are we going on? What we really want to do is find and simplify the difference quotient. So here's the difference quotient. Now let's simplify. So the first step here is going to be to expand all the stuff that's going on the top. So if we multiply out this first part, we get x times all three terms. So we get x squared plus hx minus x. And then we get h times all three terms. So plus hx plus h squared minus h. And then minus 1 times all three terms. So minus x minus h plus 1. And now we subtract this thing. So minus, and it's important that we put brackets here because this is minus this whole quantity. So whatever we expand this quantity to, we subtract the entire thing. So remember to enclose this in its own set of brackets. So this becomes x squared minus 2x plus 1. And it's this whole expression over h. But now a lot of this simplifies. We have an x squared, we have a minus x squared. Those go away. We have a minus x and a minus x. These two things give us minus 2x, but then we have a minus 2x, which becomes plus 2x. So these x terms go away. Finally, we have a plus 1 and a minus plus 1. So the 1's go away. This whole term in brackets here disappears. Now what's left? We have hx plus hx, so that gives us 2hx. We have minus h, so minus 2h. And we have plus h squared. So it's this all over h. But notice that every term in the numerator has an h in it. So we can factor one h out, and we get h times 2x minus 2 plus h all over h. Now these two h's cancel. They go away, and we are left with 2x minus 2 plus h. So it's worth noting that our difference quotient simplified into something that's not a quotient. And there's our answer.